we are starting the class on the fourth vibration. We will continue from there. So in the last class we have seen if we are having a harmonic solutions or harmonic excitation, then how the amplification is going to happen. But now all the functions may not be the harmonic. So now let's see how we can able to solve it. Like if we are having some general type of function, so we can write our equation of motion mx double dot plus cx dot plus kx, that is equal to force. So this equation is a second order second order non-homogeneous differential equation, so ordinary differential equation. So in that case you will see that once we are doing the solution, we can able to write so as it is non-homogeneous, so as it is non-homogeneous, we can able to write that x is actually x particular plus x complementary. So there will be the two part of it. So we have already discussed that complementary solution we can able to get it right like this way, that the complementary part we can get it is equal to 0, but for the and that we have seen the solution that we can write it as x equal to like a sine omega t plus b cos omega t. That way we can able to solve it. So that we have seen in the last classes. But once we are having the particular integral, then we can able to solve it like this proper form. And if you see in that proper form, we can use the d operator. So today we will first discuss about the d operator, that how the d operator we can able to implement for solving the different types of the forcing functions. So in case of d operator, we can say that d of x, that is nothing but ddt of x, or that is equal to x dot. So d2 x, that will be equal to x double dot. So like this way we can able to write it. And so far, like dn of x equal to dn dtn x, that will be x like n number of dots will be there. Okay, so this form we can able to write it m of d square plus c of d plus k of x, that will be equal to f. That we can able to write. So now once we can able to write that, so that gives me the solution. So now we can able to get the solution. So we will try to see how we can able to get the solution of that. So here, yes, so suppose if in one case, let's say we are having 4 of d3x dt3 plus 3 d2x dt2 plus dx dt plus x, that is equal to force. If we are having some of the things like that, then we can write it 4 dq plus 3 d square plus d plus 1 equal to f into x, that is equal to that we can able to write. So that, and now we will try to look that what are the different operations of the d function. So d operator is a linear operator. So d operator, L of d, so operator is linear operator. So that means what? If you have LD of C1 Y1 T plus C2 Y2 T, then we can call it C1 LD of Y1 T plus C2 LD of Y2 T. That we can say. Then we have a commutative law of addition. So commutative associative law of addition. So that actually tells us L1D plus L2D, that will be equal to L2D plus L1D, and that same thing is applicable for commutative law of multiplication as well. So in case of multiplication, L1D into L2 of D, we can able to write L2 of D into L1 of D. Okay, so you can see that it is not like a matrix multiplication, it is following commutative like a normal things. Okay, then we have a associative rule, associative law for addition. So here what we are doing, L1D plus L2D plus L3D, sorry, we can able to write it L1D plus L2D plus L3D. Okay, then associative law for multiplication also in the similar manner, L1D into L2D into L3D can be written as L1D into L2D into L3D. So all those things can be done. And then the distributive law of the multiplication over addition. So distributive law of multiplication over addition, that is telling me that is L1 of D over L2 of D plus L3 of D can be written as L1D into L2D plus L1D into L3D. Okay, so now let's take our basic equation of motion, mx double dot plus cx dot plus kx, that is equal to force, and now that force can be of different type. So let's say the force can be exponential, that is omega bar t. You may have also the force equal to sine omega bar t. You may have the force cos omega bar t. You may have some constant. So you can write it e to the power of 0 t. And we may have some polynomial of t. So for example, it can be like t plus t square by 2, maybe t cube 3, t to the power 4, something like that. So the question is that how we are going to solve for that. So first thing is the exponential. So if the function is exponential, like for example, maybe we are having d square plus 3d plus 4x, that is equal to e to the power of omega bar t. So in that case, we can write it xp, that will be equal to e to the power of omega bar t, omega bar square plus 3 omega bar plus 4. So here the point is that we are substituting d equal to omega bar. So in place of d, we can just substitute omega bar, and that will gives us the solution. Okay, so we can see that very easily we can able to get this one. Now suppose, so that is for the first one. Now if we have this trigonometric one, so trigonometric. So if I see the trigonometric, then d square plus 3d plus 4 of xp equal to, maybe I'm just putting sine omega bar t. So that is a little bit we have to do. That is like we have to do first xp equal to sine of omega bar t into minus omega bar square plus 3d plus 4. Okay, so we will get it sine omega bar t into 4 minus omega bar square plus 3d. Okay. So now it will be sine omega bar t into maybe just let's start writing it. I think 4 omega bar square minus 3d whole into sine omega t, and here it will be this whole square minus 9d square. Okay. So here the rule is that in d square you will substitute omega bar square, but you cannot able to substitute for d. Okay, so for d we cannot able to substitute anything, but for d square we can able to substitute this. So first point, we have to make everything to d square and then we can substitute. So you can see that how we did that, and once d, so here we can do it quickly. So this minus 3d into sine of omega bar t, and here we are having 4 of omega bar square whole square minus 9 omega bar square. That will become plus. Exactly. And at the top also it will be not a problem. So at the bottom, how we are getting? So at the bottom we are having this, and at the top we will have this sine omega bar t minus 3. Now d of sine omega bar t. So d of sine omega bar t, that means it is nothing. ddt of sine omega bar t, which will be equal to cos omega bar t, omega bar into cos omega bar t. So that will be 3 omega bar into cos omega bar t divided by 4 minus omega bar square whole square plus 9 omega bar square. So that will give the solution. So once that d operator is in the numerator, that's not a problem. So d operator in the numerator is not a problem, but d operator in the denominator is a problem. So you can see that how we can able to tackle the full thing. Now if it's a constant, if we are trying to do, so we have a constant. So in that case, what we are doing, d square plus 3d plus 4 of xp, that will be equal to e to the power of 0t. So now once we are having e to the power of 0t, so we can able to say xp will be nothing but e to the power of 0t, and in place of d we can able to substitute 0, means omega 0 plus 3 into 0 plus 4, so it will be 1 by 4 only. So that is why the constant one term will come. Okay, up to that stage, any problem by anybody? Any thought? Anybody? Okay, no problem. No problem. So now let's try to go for the, now try to make the problem more like a structural dynamics problem. Instead of just a mathematical type thing, now let's make it more structural dynamics type problem. So mx double dot plus cx dot plus kx, that is equal to f of t. Okay, so now I can do what? I can just divide it with in the terms with m, so that I can able to divide it to xi omega into x dot plus omega square into x equal to f of t divided by m. That we can able to write. So here, if this is d square plus 2 xi omega d plus omega square into xp, that will be f of t divided by m. Make sense? Now the important point is that this is a second order equation. So from second order equation, what can I able to write? D minus lambda 1 into D minus lambda 2 into xp, that will be f of t by m. That I can able to write. Not a problem at all. So if I can able to write that, so Next step will be xp will be ft by m divided by d minus lambda 1 into d plus lambda 2. So lambda 1 and lambda 2 are the two roots. We can able to solve that expression and we can able to get it. So for example, if you think that d of so we are having d square plus 2 xi omega d plus omega square. So what are the solutions? D equal to minus b plus minus root of b square minus 4ac by 2a. So these will be so that will become my d. So a1 and a2 we can able to place accordingly and we will get. So that will be my lambda 1 and lambda 2, lambda 1 comma 2, lambda 1 comma 2. So one will be one with plus and another with minus. So we can able to get that, and once we will get this one, we can able to represent it in form of the of this way, that d1 minus d2 plus d lambda 2 divided by d minus lambda 1 into d minus lambda 2, and if you see, then the top portion is becoming lambda 2 minus lambda 1. So lambda 2 minus lambda 1. So you can able to write it in this way. So if we rewrite it in this form, then what can we say? We can say that lambda 2 minus lambda 1 is coming here. Then here we will have 1 by lambda 2 minus d of minus d by lambda 1 f of t by. Now what can we do? You can say that this will be 1 minus so now if I try to see that lambda 2 minus lambda 1, so lambda 1 was xi omega plus minus I omega d, and lambda, sorry, that is maybe the plus, and lambda 2 will be equal to xi omega minus I omega d. So lambda 2 minus lambda 1 will be minus 2 I omega d. So what can I write? I can able to write 2 I omega d with minus lambda 1 into 1 minus d by lambda 1 into f of t by m. So now I can do the binomial expansion. So I can just rewrite it like this way. This minus 1 by lambda 1 into 1 minus d by lambda 1 whole to the power minus 1 f of t divided by m. So 1 by this equal to 1 plus d by lambda 2 plus d square by lambda 2 square plus d cube by lambda 3 cube minus 1 by lambda 1 into 1 plus d lambda 1 plus d lambda 1 square plus d cube So we can see that this type of expression we can able to get, and if we can able to express f of t in any type of like a polynomial function, that will be eventually very helpful on that. So suppose your f of t is, let's say you are having something like t to the power 5 plus t cube plus t plus 1. Okay, so here you see that the question comes, first of all, as it is the infinite series, the question comes how many terms should we need to take, and once it is like how many terms we need to take, then also second question follows that whether it will be approximate solution. Suppose if we are like as it is infinite, so suppose if we take 10 terms, will it be approximate solution? So now let's try to see what is really happening. So now point is, as it is a polynomial function, so suppose if I take d6 of this function, what will be happening? So let's see. So d6, once we are trying actually, then we have to first try like this way. So that will be d6 of t5 plus d6 of t cube plus d6 of t plus d6 of 1. So obviously if I see that, if I just start with this, so d6 of 1, that means d6 dt6 of 1. So that is equal to d5 dt5 of d1 dt. So that itself becomes 0. So d5 of dt5 has no sense, so that will become 0 automatically. So now suppose if we try to see this term, that d6 of t, now we can see that very easily that this is d dt5 of ddt of t, that will become d5 dt5 of 1, so that will also become to 0. Now let's see what happened with t cube. So that is, so this will turns to be ct square. So now once we will do it again, that will become 3 6, that will become 6 into t, that will become 6. Now ddt of 6, it will become 0. So what about D65 if you do. So what can I say? That is like first one obviously like D5 into ddt of D5, so D4 into d of 5 D4 into D3 of d of 20 T cube equal to d square of d of 60 T square, that is equal to d of d of 120 T, that will be equal to d of 120, that will be equal to 0. But if we are doing d of 720 T, and that is equal to 720. So you can see that once that two term like d of in and t of in are matching, then only we can get the solutions. All the previous term before that will lead to 0. Like once the d term is more, like suppose di and tj, if I is greater than j, so that will leads to 0. Simple. So we do not need to consider those higher order terms of the d in that expansion. So like you can see here that so many terms of d are coming, but we have to check that f of t, what is the maximum order of that. So once the f of, so suppose if we found that f of t is going up to like a fifth order polynomial, so we will take d up to d to the power 5. That's all. After that we don't need to take, because they will automatically becoming 0, and as they are becoming 0, we and all the terms are 0, so it is not any truncation, it is exact solution. So this way we will get the exact value. There is not any approximated value that we are taking more term or less term, because if you take more term, solution will not change at all. Okay, because all the terms will become 0. So that we have to check and we have to do accordingly, and that will gives us the proper way of giving the solutions. So I think you can able to solve this problem, that okay, how it will come, and you will get that complete expansion in the right hand side. So if you see, or maybe if I just quickly do that, so like what was the main equation? And additionally, the important point is that you maybe have some different types of your excitation. So you may try to fit some sort of polynomial if it is possible, so that you can try to get some sort of accurate type of result. Okay, if we are having load like this way, that is going up and then going down. So here we can see, so then we just try to do the next case, that is like, for example, your structure is subjected to a force which is increasing at up to a certain time, and then it decreased. It can happen in many cases. So how we can able to solve this thing? So first of all, we have to write the equation of motion as it is, like as usual, mx double dot plus d is equal to maybe alpha t. It is increasing with the slope of alpha, and maybe it is decreasing with the slope of beta. Okay, and then so that is 0 less than t less than t1. Okay, and at that value of t1, once it reached, so this has a particular force, that is alpha 1 minus, now it is getting decreased, so that is beta, way it is decreasing, so beta times t minus t1. So that way we can able to get this. So that will be t2 less than t less than t1. So that is defining the way how it is getting decreased. And after that maybe there is no force. So we can say t greater than t2, that the force is becoming 0. So in this type of scenario, what we have to do? We have to solve the system for each of their parts. Like first portion, first phase, once we are considering, we have to solve it up to this, and we need to remember that we should not solve it for the value of time more than t1. So it should be restricted up to the t1 value. We cannot cross that t1 value. Okay, so we can solve it, and as we have discussed the several methods, we can to do it, and once we will calculate the displacements and the velocity at t equal to t1, that will act as the initial condition for the next step of the solution to start. And additionally, what we can do, so first, like, we can solve it. So mx double dot plus cx dot plus kx, that is equal to alpha t. Okay, so we can solve that. So we will get the complementary part, we will get the particular part, and our total solution will be xc plus xp. We will get total solution, and we can also able to see that x t1 we can go up to t1. So that value and x dot t1, so these two act as the initial condition for phase 2. So that is my phase 1, this is my phase 2. Okay, so for phase 2, what it will happening? For phase 2, you will have x double dot cx dot plus kx, that will be alpha t1 minus beta t minus t1, like this way we will get that. Okay, and here additionally one important thing is that we can introduce another parameter, that is tau. So tau will be something like t minus t1, so that this tau can be like start from 0 and it will go, and that tau will go up to maybe t2, and after that t2 you can, or maybe you can say it is like tau 1. So tau 1 is going to that, and then again you will start tau 2. So then tau 2 will act from t minus t2, so that you will take all the things from tau 2. Okay, so like this way we can able to get the solutions. We will start doing the Duhamel's integral. So let's say you have your system, you are having some sort of functions of the force. Okay, now that force can be thought as like you are giving an impulse to the system. So if you think that like at this time you are having an impulse on the system, then what will happen? So what is impulse? If we try to recall in our school days, we have studied all the time that, like, suppose once is doing the batting and something, so the ball come and they hit So that's some sort of like an impulse. That so impulse is some sort of like a collision where we can say that the change of velocity is instantaneous, and due to impulse what happened, they have a instantaneous change of momentum. Okay, so we can say that if the I amount of impulse is imparted on the object, so if I impulse imparted on object of mass m, then its velocity change will be I by m. Why? Because momentum is defined as the change in velocity, dv, that is equal to I, so delta v will be I by m. Simple. So if a system is at rest and it's subjected to a I amount of impulse while the system's mass is m, then what will be its initial velocity? So initial velocity, we can say that x dot will be I by m, and maybe the system has its initial position. This is the displacement of that, and so this is the scenario. So what is the solution for that case? So we know that the solution will be e to the power psi omega t into x0 cos of omega dt plus x0 dot plus psi omega x0 divided by omega d into sine of omega dt. That is the solution of that system subjected to this. Now if you see, your x0 is equal to 0 and x dot 0 equal to I by m. So what can we get? E to the power this into 0 plus I by m minus 0 I by m into omega d into sine omega dt. Okay, so we can say that this is my solution. So that will be the solution once the impulse is imparted on the object. Okay, now if you think that this thing is happening in a very continuous manner, like for example you have this type of loading, and here you have seen that this impulse is happening, then again you are having impulse, again you are having impulse. Means what I'm doing, I have that full force thing, and I'm trying to dividing it into small bits and considering it that as an impulse. So after like tau time, that impulse is occurred. Okay, so I know my response will be this much. Yes, so if we think that impulse imparted at t equal to tau, then what can I say? T minus tau will be e to the power of psi omega t minus tau into I by m omega d into sine of omega d into t minus tau. Make sense? So does that make sense? Perfect. So if it makes sense, then we can say that now this thing is like for one impulse you will have that, for other impulse, you will have the several types of values. And additionally what happened, these I, how you can able to calculate? So I you will be f of tau, so that one is your I, the that impulse value. Yes, so that impulse values you have to just calculate it. And these, so for this first impulse you will have this response, then for second impulse you will have second another response, third another response. So like this way you will have a series of these responses, and your resultant is actually the summation of all these responses. So you can say that summation, that x, which will be nothing but integral from 0 to total time into e to the power of minus xi omega into t minus tau into f tau divided by omega d into sine omega d t minus tau d tau. So that will be your original response of the full system. So by this way also we can able to solve the problem, provided if we know the f of t in that linear. But here we will found some difficulties because that integral is not that simple, because we are having like a three different terms, and once we are doing the integration of the three different terms, that is very difficult actually. So yeah, so that is the like the different methods how we can actually able to solve it. So thank you very much. So we will go ahead from further in the next class and try to see. Thank you.